Hi again, everyone. We're talking about integration now. And integration is, what is an integral? It's the area under a curve. It's a measure of the area under a curve. So the way we get it, we add up a bunch of rectangles under the curve. And the more rectangles we add up, the closer we get to the actual exact value of the area under the curve. So this is section 4.1, problems 21, 22, and 23 all have the same flavor. You're supposed to take them and put them in the form of what they say is definition 2. Definition 2 says the final area is the limit as n approaches infinity. What is n? N is just the number of rectangles. N is just the number of rectangles. We're taking an infinite number of rectangles. We're taking the limit as n approaches infinity. So, and what we do, so for each one of these, the delta x is the width of the rectangle. So we're going to take a bunch of rectangles. The delta x is the width. And it's convenient to keep the width uniform. It's not going to make any difference, so why not? Then these, f at x1, f at x2, f at xn, okay, x1, x2, xn, they're x values within that width. And we use that x value to calculate the height of the rectangle. So like this height, if we're in the first rectangle, this height would be f at x sub 1. If it's a left-hand sum, it would be what the curve would hit here, right? If it's a right-hand sum, the curve would hit here. If it's a midpoint, the curve would be hitting right there. Okay? Now that's just the first rectangle. How can I want to write this so that I'm including every rectangle. So instead of x sub 1, I'm going to use x sub I. The height of rectangle I. Or the ith rectangle. So if it's the first rectangle, that's the first. If it's the second, that's the height of the second, and so forth. Okay, so we've got to write all this down for this function. Okay, so let me go back to that specific function and write something. Okay, so we're going from 0 to pi. We want delta x to be the same in each one of these. Makes it easy. The same width for every rectangle. So if we have n rectangles, that's the number of rectangles, let's make our delta x pi over n. So we've cut them up. Each rectangle is pi over n. So if we have 8 rectangles, each width would be pi over 8. Okay, now how are we going to write f at x sub I? Okay, f at x sub I is going to be the square root of the sine of x sub I. But we want to do better at specifying that. Okay, so let's say we have a picture like this. Our rectangles start at 0. Let's say we're going to use the left-hand Riemann sums. It doesn't matter which sum you use because n is going to go to infinity and you're going to get the limit regardless of which one you use. So I'm going to say let's use the right-hand sum. So the left-hand sum, sorry. So the first rectangle would be whatever this height is, would be f at 0, whatever that height is. And the width would be like this, right? Pi over n. The next rectangle, so the next rectangle would be still pi over n, but its height would be f at pi over n. This first value here, right? The next rectangle, we would go to 3 pi over n, and let's say we would be this high. So our height would be f at 2 pi over n. So we can see that we go, this is 0, then we're going to go to pi over n, 2 pi over n, and how far over are we going to go? At the last rectangle, we're going to end at pi, but what would this be? However many n is, it would be 1 less, right? So it would be n minus 1 times pi over n. So this was 0, this was 1 pi over n, 2 pi over n, 3 pi over n. We keep going. We don't want to go to n pi over n because we're doing a left-hand sum. We want to go to n minus 1 pi over n. So what we can do is we can write this as we got to figure out how we can write that. So we can write this. This is going to be I. Could it be I pi over n? Well, no, because we're starting at the left-hand side. So it can be I pi over n as long as I goes from 0 to n minus 1, right? Because we're taking the square root of the sine of the left side. Okay? So how do we write that? Well, the standard way to write it is to say a equals the limit as n goes to infinity of the sum as I goes to 1 from 0 to n minus 1 of the square root sine of I pi over n times pi over n. So that's what we would wind up with. See you next time.